Seeing the Future, AI in Computer Vision. Insights from 42 papers, dated July 20th, 2025, presented by AI Frontiers, exploring cutting-edge advancements in visual AI. Presentation overview. Diving into computer vision innovations. Imagine AI that sees better than humans, faster, ethically, and in real-world chaos. These 42 papers are unpacked here, covering themes, findings, methods, and spotlighting 3 standouts. The journey spans from field basics to future visions, blending excitement with technical insights. This is perfect for enthusiasts and newcomers curious about smart cameras and beyond. Field overview. Understanding computer vision. Computer vision empowers machines to interpret images and videos like human eyes and brains. Key applications include healthcare diagnostics, autonomous vehicles, environmental monitoring, and augmented reality. It is driven by deep learning neural networks and vast datasets for object detection and scene reconstruction. These 42 papers showcase efficiency, multimodal integration, and ethical AI in visual processing. Research themes. Overview. Dominant directions in computer vision. A key theme is image enhancement for challenging environments, improving clarity in real-world apps. Medical imaging applications focus on precise detection and health monitoring. Multimodal learning integrates vision with other data for richer AI understanding. Efficiency and benchmarks drive practical, robust systems. Let's explore each. Beam 1. Image enhancement and restoration. Boosting visual clarity. Methods fix distortions in underwater or satellite images for conservation and monitoring. Verma et al. Use graph representations to enhance event-based detection efficiency. Ethical approaches tackle biases, like in coral imaging, ensuring fair AI outputs. Core concept. Diffusion models iteratively denoise data for high-fidelity results. This ties to real-world impact. From industrial automation to environmental protection. Theme 2. Medical and biological imaging. AI as a health partner. Focus on detecting issues like bleeding in surgeries or heart rates from videos. Comas et al. Introduced transformers for motion-robust heart rate estimation. Simulations improve ultrasound tomography for better cancer detection. Technical idea. Transformers use attention to weigh important image features. This advances non-invasive tools, potentially saving lives in healthcare settings. Theme 3. Multimodal learning and efficiency. Integrated and optimized vision. Blends images with text or 3D data for tasks like robot action prediction. Yang et al. Enabled training-free virtual try-ons for multi-person scenes. Efficiency optimizations cut energy use on devices, like in video classification. Concept, self-supervised learning adapts models without labeled data. This overlaps with benchmarks, exposing AI gaps in reasoning and generalization. Key findings. Breakthrough insights across papers. Event-based graphs by Verma et al. Boost detection accuracy by 6% and speed by 5x. OmniVTON achieves first multi-person virtual try-ons with superior fidelity. BeatFormer hits top heart rate accuracy despite motion, enabling remote monitoring. Benchmarks reveal AI reasoning gaps, urging robust video intelligence. Efficiency methods cut energy by 40% while improving accuracy on devices. Methodology. Synthesizing common approaches. Graph-based models preserve sparsity for efficient event data processing. Transformers capture dependencies in images, though compute-intensive. Diffusion models generate high-fidelity outputs via iterative denoising. Self-supervised learning adapts pre-trained models without labels. Strengths, scalability, and robustness. Limitations, high compute and potential biases. Selected Research Paper 1. Event-based graph representation with spatial and motion vectors for asynchronous object detection. Verma et al. Selected for innovation in efficiency, representing event-based vision theme. Objective, preserve sparsity for low latency detection in autonomous systems. Method, spatiotemporal multigraph with B-splines and motion attention. Findings, 6% accuracy gain, 5 times speedup on automotive datasets. Significance, advances edge AI. Inspiring sparse data handling in robotics. Selected research paper 2. OmniVTON, training-free universal virtual try-on, Yang et al. Chosen for novelty in generative techniques, impacting fashion and AR. Objective, enable realistic clothing swaps without training or artifacts. Method, decouple garments via diffusion models and boundary stitching. Findings, superior fidelity in meaty person scenes, outperforming baselines. Significance, democratizes e-commerce, reducing biases in virtual representations. Selected research paper 3. BeatFormer, efficient motion-robust remote heart rate estimation through unsupervised spectral zoomed attention filters, Comas et al. Picked for representativeness in medical applications and unsupervised innovation. Objective, accurate heart rate from videos despite motion without labels. Method, lightweight transformers with spectral attention and contrastive learning. Findings, top performance in cross-dataset tests. Efficient for real-time use. Significance, scales non-invasive health monitoring, setting biovision standards. Future directions. Next steps in computer vision research. Expand training-free methods and ethical frameworks for bias reduction. Develop hybrids of graphs, diffusion, and language for data-scarce tasks. Focus on robustness to adversaries and sustainable edge computing. Integrate neuroscience for adaptive, human-like visual AI systems. Address challenges like computational demands and open set generalization. AI synthesis and review. How this deck was created. Synthesis created using AI tools. GPT Grok with model Grok 40709 for content generation. TTS synthesis via OpenAI for audio elements. Image generation using Google tools. Underwent review by a human expert to ensure accuracy and coherence. While reviewed, acknowledge potential oversights may exist. All references provided. Subscribe in channel info. Join the AI Frontiers community. Subscribe to our YouTube channel for more exciting AI research breakdowns. Channel, AI Frontiers. Description. Stay updated on the latest in AI. Hit subscribe and turn on notifications. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight for arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.